Hi everyone, Adam here from the 3D Measurement Company, and today we're talking about 3D scanning in the automotive industry. Where is it most used and why is it so important? As some of you may know, T3DMC have specialised in the field of 3D measurement for almost a decade now. Through that time, we've been involved in a whole raft of applications around the automotive industry. However, the uses largely are centred around three key areas. Firstly, we have benchmarking. Secondly, we have aftermarket product development. And finally, we have quality assurance and quality control. Right, let's get into it with these topics. What are they and how is 3D data helping? Firstly, we talk about benchmarking. For those of you who don't know, benchmarking is the process of comparing similar products in a structured and validated way. For the automotive industry, this means comparing exterior and interior features. We look at bodywork, we look at shape, we look at size, and we can look at weight. For interiors, it can be anything from material uses, size and shape of seats, the position of the seats relative to the steering wheel, the position of rear seats to front seats, the depth of the dashboard, the driver position to the center console or the steering wheel or dashboard, the position of pedals relative to the seats. The list goes on really. The key here is that 3D data is at the very heart of effective benchmarking, as it allows customers and engineers to gather more information about a vehicle, and as such, it plays a real pivotal role in cataloguing all elements of the vehicle, including assemblies and sub-assemblies during the teardown process. When it comes to benchmarking here at T3DMC, we look no further than the Scantec track scan. There's no dots with this system, so there's very little setup time, and with the use of 42 blue lasers capturing over 1.5 million measurements per second, we get excellent results in a fraction of the time of other methods. In addition, because this is a laser-based technology system, we're able to get excellent data even off the most challenging surfaces like chrome and gloss black, which means that we're not having to use any mattifying agents to dull down those surfaces, which means that we're not having to deal with any cleanup or harmful sprays in our customer environment. Next, we have aftermarket product development. Now this one is brilliant for me as it really opens up the creative side. We work with companies large and small in this area. We have had individuals approach us because they have a customization project they'd like to work on. One customer of ours wanted to integrate a mobile phone charging pad into the center console of his vehicle, so we were able to work with him on that. We've also worked with larger companies who are developing full body kits for luxury SUVs. We also have a customer who are developing protective wraps for sports cars. Previously, it took the laborious task of templating the car with paper and tape, which was also not particularly accurate for them. And now they are in a position where they can 3D scan half a car in less than 30 minutes, giving them the data they need to produce CAD renders so they can create cutting paths for their film wraps. This has now shortened their process time by up to 75% and reduced waste to almost nil. For these vastly different applications, the fundamentals are the same. High quality 3D scan data allows for our design team or a customer's in-house design team to produce highly accurate CAD models of the physical real-world part very quickly, so we can get to the prototype stage in a matter of days rather than weeks as it perhaps used to be. Plus, with the advantages in SLA 3D printing technology, we're able to print parts up to 1.5 meters for accurate fit and function trials, which vastly speed up the development process. But it all starts with high quality 3D scan data. Finally, and now arguably the most important, is quality control and quality assurance. Using 3D data for inspection transforms this process. Engineers no longer have to look at long tabulated reports with XYZ values, plotted with specific names that need to be referenced elsewhere to understand where that value was taken from on a part. With 3D data, we can create full colour plots which show the full story of a part versus design CAD. We can then use the CAD to interpret the scan data, creating holes, trim, GD&T features too, with tolerances all set automatically from the CAD model, allowing operators to create detailed reports very quickly and very easily. Furthermore, and I'll take you in there to see, we offer full inspection services to customers all over the UK. So we're in the inspection room here, and this is where our customers send our parts, and they're stored in here. It's a temperature stable measurement room, and behind me we have our automated system. So if customers want to create a statistical analysis of their parts over a large batch, then we would do it with an automated system. But we have plenty of space around here for doing the portable measurements as well, and the one-offs. Have Scott behind me working on the probing solution, which is part of the K-scan range, which allows us to capture hard features as well. And that's it. Quality and inspection is the final piece of the puzzle of how 3D data is used in the automotive sector. It plays a huge role in speeding processes up, offering greater accuracy, and most importantly, offering more comprehensive results than ever before. As always, thank you very much for watching. I hope this was useful to you, and I look forward to seeing you in the next video. Thank you.